Hi students, this video is going to go through some factoring of polynomials. This is really going to be about polynomial division as well, because in order to factor some bigger and scarier polynomials, we need to divide first. All right, so we've got a fun polynomial and we're dividing by x minus 8. To do this, I'm going to use synthetic division. If you haven't learned synthetic division before, we're going to go through that right now. I'm going to take my coefficients and I'm going to kind of build this weird box for them. So I've got a 2 and a minus 15 and a minus 7 and another minus 7. We're doing this just so we can leave out the x's, just the coefficients. I then need to identify what the 0 would be for the factor x minus 8. That's going to be x equals 8. And I'm going to put that out front. Synthetic division is always the same process. It's weird, but it's not a difficult process for us to use. We always bring down that first term. We then multiply. 8 times 2 is 16. And then we add going down. Negative 15 plus 16 is 1. We're going to multiply. 8 times 1 is 8. And add going down. Negative 7 plus 8 is going to be 1. We're going to multiply. 8 times 1 is going to be 8. And add going down. Negative 7 plus 8 is going to be 1. At this point, the synthetic division part is done. The last number here is always our remainder. And I'd like you to remember when we're dividing polynomials, we always take that remainder and put it over our divisor. That's what's written here. So in this case, that's going to be 1 over x minus 8. I'm going to kind of build this backwards. And we're going to increase a degree each time that we go. So if I were to go from a remainder, now we have just a number. And then we are going to have our x term. We're increasing the degree by 1. And then we're going to increase our degree again. Instead of x, we have x squared. The why this works is because we're really just doing long division, but we're cutting a lot of the pieces and a lot of the work out in order to make this go faster. We do this because there are problems that we have to do synthetic division quite a lot for. And if we have synthetic instead of long division, we can do that much more quickly than we could otherwise. The other thing that we have to be really careful with is our polynomial and the degree of each term. We've got 2x cubed, negative 15x squared, minus 7x, and minus 7. There's a term for each degree, and I'm including each of those terms in my setup. If we had skipped a term, we would still have to include that term in our setup with a coefficient of 0. So in terms of synthetic division, we got to be a little bit careful, but the work is much shorter than we would otherwise need. All right, here we're given a quadratic. We're told what the remainder is, which is 81. I'm going to slide that a little bit. And we're asked to find the value of k. This has to do with the remainder factor theorem. The big idea is that if I'm dividing by x minus 4, actually it's very little to do with the remainder factor theorem. This is just a problem that we tend to see with that. So the remainder factor theorem is if I divide by x minus 4, that would be the same thing in terms of the remainder as if I plugged in x equals 4. So we use these things kind of interchangeably to see what's going on here. Oh, I guess I could do it that way. That'd be fine. I'm going to do this 2 different ways. This is going to be fun. So I'm going to set up my synthetic division. We've got 3 and then a k and then a minus 7. I know that x minus 4 is going to be x equals 4 out front. And my remainder is going to be 81. So 81 has to be here. In these problems, we tend to work forwards and backwards at the same time. To get from negative 7 to 81, we know we have to add 88. There's no other way that I can get there. And to get from whatever number is here to 88, I've got to multiply by 4. Something times 4 is 88. That something is 22. So then we end up with this k plus something is 22. We don't know what that is yet. Okay, so I'm going to work forwards. I'm going to bring my 3 down. 4 times 3 is 12. K plus 12 is 22. That means that k has to be 10. All right, then making use of the remainder factor theorem, which is what I thought I was doing originally. The big idea is that f of 4 is also going to give us 81 as an answer. So let's plug it in and see what happens. So f of 4 is going to be 3 times 4 squared plus k times 4 minus 7. 3 times 4 squared is going to be 16 times 3 is 48. Minus 7 is going to be 41. Sorry, I'm doing lots of steps at once in my head and trying to keep up on paper. So we end up moving that to the other side. And we end up getting 40 is equal to 4k, which means that k is 10. All right, so we need to figure out which of these is a factor of this beautiful polynomial. I don't know which one it is to start with, so I'm going to go through all of them. We're not missing any powers, so I'm going to build my synthetic division. 1, 1, negative 46, and 80. And I'm going to try my first one with 8. So we are going to bring that down. 8 times 1 is 8. Add up to get 9. 8 times 9 is 72. Negative 40 plus 72 is 32. Minus 6 is 26. That's going to be like 160, 208. And then that's 288. Since that's not 0, this is not a factor. All right, so let's set this up again. 1, 1, negative 46, and 80. Now I'm going to try negative 5. So we've got 1 coming down. That comes to minus 5. All right, negative 5 times negative 4 gives me positive 20. That's going to give me 26 on the negative side, and negative 26 times negative 5 is 130, which is 210, not 0. Cool. Third one. We're going to have negative 8, and then 1, 1, negative 46, and 80. Bring the 1 down, negative 8, negative 7, 56, that's 10, negative 80 gives me 0. Yes, this is our answer. All right, we're looking at the same type of problem. I'm going to do synthetic division again. Here we got 1 and 6 and negative 19, negative 84. I'm going to just start with the first one, so that's negative 1. 1, negative 1, adding up, we get positive 5. Negative 5, which is going to be negative 24. 24, which gives me negative 60, not 0. Negative 7. 1, 6, negative 19, negative 84. That gives me negative 7, negative 1, positive 7, negative 12, positive 84, and 0. That's our factor. The big idea is that if we plug a number in and we get 0 as an answer, it's the same thing as showing that we get that whatever that is the 0 of, in this case x plus 7, would be a factor. All right, here we're looking at a polynomial. We're given 1, 0. And if f of negative 5 equals 0, that also means that x plus 5 is one of our factors. To find these zeros algebraically, what we're going to do is divide first. So I'm going to have negative 5 out front. 4, 16, negative 23, negative 15. That's going to be 4, negative 20, negative 4. It's going to be positive 20, negative 3. And then we're going to have positive 15 and 0. Okay, we knew that was going to happen. We don't have a remainder, so this is going to be minus 3, minus 4x, and then 4x squared. So this is going to be factorable, we hope. I'm going to multiply my a times c terms, and then when I do that, I get negative 12x squared. My b term is negative 4x. Things that multiply to negative 12x squared and add up to negative 4x, that sounds to me like negative 6x and 2x. So we've got 4x squared minus 6x plus 2x minus 3. Factoring a 2x out of those two, that's as big as I can take out. We're left with 2x minus 3. And then I'm going to factor a 1 out of those two, and I get 2x minus 3. That leaves me with 2x minus 3 and 2x plus 1. My zeros from that, 2x minus 3 equals 0, gives me x is equal to 3 over 2. And 2x plus 1 equals 0, gives me x is equal to negative a half. That will be it for this problem and this video.